Follow Shadow Junior Twin.
Hello everybody, today I'm going over A-Level Stats 2024 paper. Quite a nice paper, and I'm going to try to get this done in less than 5 minutes. Let's stop waffling, let's get straight into it. So, question 1. We're told that this guy, don't know how to pronounce his name, rolls a fair die 10 times. And this letter word fair tells us a lot about what we need to do already. And it tells us what distribution we're going to use too. And then the random variable x represents the number of times that lands on a 6. So we know this is going to be a binomial distribution because we're given a fixed number of times, and we know the probability because it's a fair die. Each number has a sixth chance of being landed on. We're going to assume it's a six-sided die. Anyways, so once we have the binomial distribution, we can just work out these probabilities very easily by just plugging it into our calculator. And those are 3 marks. Okay, part B. He repeats this experiment on each day for 60 days and records the number of days when x equals 3. So we're creating a new distribution for this. We have 60 days, that's going to be our sample size, but the probability isn't going to be a sixth anymore, because we're trying to find the probability when x equals 3, which we actually worked out here. So we then plug in the number we worked out here as the new probability in the new distribution, and then we just have to do more binomial distribution to find the probability that there was at least 12 days when x equals 3, so we're doing x is greater than equals 12, and we work out that probability there. Part C is just a nice question. Find the estimate for the total number of sixes that whatever his name is will roll during the 60 days. We know he rolls a die 10 times per day and he does the 60 days. So we're doing 60 times by 10 for the number of dies he rolls. And the number of sixes, the expected value is going to be whatever the number is here divided by 6, because there's 6 numbers it could land on. It's just 100. And for part D, we're doing a normal approximation. So here we're going to use NP equals mu for the mean, which is 100, and then the variance is going to be NP times by 1 minus P, which is 250 divided by 3. So that's going to be our distribution here. X is approximately the normal distribution of 100 as mean, and 253 over 3 is the variance. And then we have to do a continuity correction. We're asked for more than 95 sixes. However, since we're doing an approximation, a binomial distribution is a discrete distribution, meaning we only take integer values when we're working out probabilities. The normal distribution is continuous, meaning it could have decimal values and like any of these numbers between integers. So we have to do a continuity correction. Anything that was greater than 95.5 will round to 96. If it was 95.4, it would round to 95. We want numbers that are greater than or equal to 96. So that's why we do this continuity correction, and this is the probability we get. Next question. Let's go. Good pace. So we're told a bit about a bird that is flying h meters above the ground at time t seconds, and we're told that there are 10 values of t. There are 10 values of t that were taken, which is important for part B. Anyways, we're given the equation for h in terms of t, and we want to interpret the gradient of this line. Well, we already know this is going to be the initial height here, and it's going to decrease over time because the t value is going to increase this number here. And so the gradient, which I wrote here, is a number of meters, 1.28, the bird falls per second. We're just literally putting it into words what this gradient will be, and this is the gradient because it is the coefficient of t. Then part B, we're told that the PMCC for h and t is minus 0.51, meaning the correlation isn't very strong or very weak, but it's a negative correlation, right? It's minus 0.51. Remember, we know that there were 10 values of t taken. So what we can do is we can go into the formula booklet and find the R value for a sample size of 10 at a 5% significant level, which was mentioned here. So what that does is gives us a value of 0.5494, and then this is greater than the value given here. So the chance of the randomly appearing to be a negative correlation is actually greater than the correlation we got. So we accept H0, meaning that the correlation is that there is actually no correlation. There's insufficient evidence of a negative correlation between H and T. We say insufficient evidence because this is all probability and all chances. There could be a case where there actually is a negative correlation, but the evidence doesn't support this. So then part C, with reference to the scatter diagram, state giving a reason whether or not the regression line blah 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 is an appropriate model for these data. So as we can obviously see, we're forming a curve here on the scatter diagram. So you can just say no, points follow a curve, not a straight line, and this equation here is just a straight line. Part D. Jane suggests an improved model using the variable u equals t minus k squared, where k is a constant. She changed the equation this. Choose a suitable value for k to write Jane's improved model for h in terms of t only. So first of all, we sub in u, which was given here, we sub it into here. to get this. And we know the maximum value for h occurs when t equals 3.5. If we look at this graph, it's around 3.5, maximum value is 40. So obviously this isn't ideal, but we know that the maximum value is going to be when this here is equal to 0. This is always going to be positive, this a little bit here, so therefore this is always going to be negative because we're timesing it by a negative number. So the maximum is going to occur when this is equal to 0, so k is going to be 3.5. Move on very, very swiftly. We've already over 5 minutes, we failed the task. Anyways, large data set, the worst topic that could ever come up. Ming is studying a large data set for Perth in 2015. He intended to use all the data available to find summary statistics for the daily mean air temperature. Unfortunately, Ming selected an incorrect variable on the spreadsheet, blah, 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 blah. The incorrect variable gave a mean of 5.3 and a standard deviation of 12.4. Not gonna lie, I low-key just guessed this. I've already sat my A-level, so I don't actually study the large data set anymore, but I had an educated guess here. And the reason why I went with daily mean rainfall, which is correct, is because the mean is quite low, which you'd expect for rainfall in millimeters, but the high standard deviation is high. And if you get a storm or a bunch of bad rain, this would cause a high standard deviation compared to just days with 0 rain at all. So that's why I went daily mean rainfall, and it was correct. The large data set is kind of relevant. You won't get more than 4 marks on a stats paper for large data set. If you are struggling already, I would recommend low-key just skipping the large data set. I will make a video at some point covering the stuff you need to know for large data set, but let's move on from that. So, part B is just some normal calculations. We know the formula for a mean, so we just plug in the numbers. We know the formula for SD, it's also in the formula booklet, both of these. Plug in some numbers and you get the answers. In part C, another large data set question. So we're told that one of the months for the large data set for Perth gave a mean of 19.4, standard deviation of 2.83. So I already said that our mean given is higher than the mean we calculated here. So it's quite hotter. It's a hotter month. And we know in Australia's backwards, Bun's place. So the summer months are the winter months in the UK. So the latest that the large data set goes is October. The large data set goes from May to October. So we want as close to winter as possible for the UK, which is as close to summer as possible, which is October. Next question. This is a nice question. So we're told some data about left-handed adults in a country. We're told that the proportion to right-handed is 10%, or 1 to 10. And Freya believes that the portion of left-handed adults, blah, 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 is different. So we're just doing a hypothesis test. So what we want to do is we want to create a distribution, a binomial distribution with a sample size of 40, because how many people she selected, and a probability of 0.1, because that's how many left-handed people there are. We're saying the null hypothesis is that P is 0.1, and H alternative hypothesis that P doesn't equal 0.1, right? Because we're told she believes that the portion of left-handed age in the country is different from 10%, not less than, not greater than, different. So this is going to be a two-tailed test. So we're actually trying to make the probabilities as close to 0.025 as possible, not 0.05, because we're told that it's 5% significant level. Since it's two tails, trying to get it as close to 0.025. And we can do that by just plugging into our calculator, and we get these two values. So that's going to be the critical regions. So in part B, we're asked to write down the actual significant level of part A. We just add these two probabilities together. Remember, the binomial distribution is discrete, so we're not actually going to get exactly 5%. We're going to get an integer probability, which is going to give a number that is slightly different from 5%. In this case, it was 3.03%. In part C, we're told that she got 7 adults that were left-handed, and since this actually doesn't fall within the critical region, we're told that we accept H0. There is insufficient evidence to support a change in proportion of left-handed people. The number wasn't high enough or low enough to actually suggest that the probability is not 10%. But there's still 2 more questions left and we're 9 minutes in. Okay, Jesus. Okay, the record for school's athletic club shows the height H meters achieved by students in the high school jump is normally distributed with a mean 1.4, standard deviation 0.15, find the proportion of students, blah, 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 blah. Just basic, plug into the calculator, form a distribution, plug into the calculator, you get this probability. Part B, it talks about some more waffle, which we're going to use in part C. You can read through that now. But then we're asked to state a necessary assumption about H and T for the head to calculate an estimate for this proportion. So, the reason why the answer is that they're independent events is because if they were dependent on one another, the probability of achieving like a very high score in the one will affect the probability of achieving a high score in the other. But since they're independent events, you're able to do calculations. You're able to do calculations that, like this, where you're trying to work out the number of people who can jump higher than 1.6 meters and run 1500 in less than 5 minutes. Holy, I'm trying to waffle because I really want to keep this short. Anyways, Part C, find the head's estimate of the proportion. So what we need to do is we create a new distribution and we do it for the 1500 meters. We work out the probability that it's less than or equal to 300. We get this. So the probability that they run 1500 meter less than 5 minutes and jump above 1.6 meters, we can just times these two probabilities together, giving this. Next, Venn diagrams. Last question, very easy. So, state any pair of mutually exclusive events of AB from A, B, C, and D. Mutually exclusive means that two events are not overlapping on the Venn diagram. So I just said AC. Nice. Part B, we're asked to find the value of P. And since B and C are independent, we're told here, the probability of B times by the probability of C is going to equal probability of B and C, which I used here. I already worked out the probability of B and probability of C, because you can just add up these numbers and add up these numbers. Once you times it together, you get the intersection, which is 0.27. So P equals 0.13. Nice. Okay, part C, we'll find the greatest possible value of probability of A given not B. So we can work out the probability of A given not B using the formula in the formula booklet. We can represent it like this, and then we can use the Venn diagram to actually extract what these are. And it's Q over Q add 0.33 add R. Additionally, we have this equation here because all the probabilities within the Venn diagram are going to total 1. That's how they work. So we can form the equation Q add R equals 0.22. What we're trying to do is trying to maximize this fraction right here. And to do that, you want to make the denominator as small as possible and make the numerator as big as possible. So to do that, we can actually try to make R equals 0 and Q be as big as possible. And that will maximize this fraction. So we're trying to set R to be 0, and then Q would therefore be 0.22. So the maximum value of this would be 0.4. And then part D, we're given more information. We're given that the probability of B given not A is 0.5. Find the value of Q and R. So for that, we are just going to, write out this expression as we did before using the formula. Then we use the Venn diagram to actually work out what these probabilities are, and we get 0.5. So we can just solve this equation for R to get 0.07. And then remember, Q add R equals 0.22, so Q is 0.5. Okay, E. Find the probability of A or B not and C. Okay, so A or B not would be A or B would be this. So then not that would be anything outside of this. But then and C would be these information, right? It's not in A or B, but it's also in C. So it's 0.08 add 0.25, which is 0.33. And then part F is use set notation to write an expression for the event with probability P. Oh, circle that. Okay, and we're trying to find a probability of P here. Let me rub this out. P is going to be in B, but it's not in A and it's not in C. So we can just turn those words into set notation. We're saying it's in B and not C and not A.